I read the book, and I wrote him back another letter. I said, Dr. Ross, either Dr. Connolly was misinformed or you just couldn't remember what you wrote in your book, because I bought your book, Creation and Time, and it didn't touch on even remotely anything I asked you about. But I did find about 16 more things that I think is scripturally and scientifically wrong. So I questioned him about that. Well, he didn't answer me. So I've written it about 3 times, and he doesn't want to answer me, but we're going to talk about some of his books and his writing a little bit later. You know, it's not just some books like that either. How about Dr. Seuss? Now, I'm over here, and I can't see this real good. I'm going to have to move over a little bit. From fossils, dinosaur teeth, eggs and bone got stuck in the muck, and the muck turned to stone. These fossils are old. They're dusty and worn because they were made long before you were born. Not hundreds of years, not thousands of years, but millions of years long before you were born. Probably some of you have this home. You let your kids read this stuff. You know, we got to be careful what our kids read and what they watch on TV, because they're getting this billions of years stuff, and it affects their whole worldview. After a while, if they hear it from enough people that they trust, they might start believing it. And they might start doubting the Word of God. Now, we talked last week about the scientific method. We're going to use the scientific method again tonight. Let's be scientists. The first thing we do is we define our problem. And the problem is, how old is the Earth? So we're going to define our problem by asking a question. How old is the Earth anyway? Now this gathers some information. Did you know that some of our planets in our solar system are cooling off too fast? Did you know that? For example, did you know that Jupiter is losing heat twice as fast as it's gaining it from the sun? Why is it still so hot? You know it should be very cold by now, but it's not. Why is it still so hot? Here it says Jupiter's moon Ganymede has a strong magnetic field. Magnetic fields are generated by the liquid motion of molten metal inside a body, yet Ganymede should have cooled solid billions of years ago. Well, why didn't Ganymede cool solid? How come it's still so hot if it should have cooled solid billions of years ago? That's an interesting, there's some bit of information they should have in our textbooks. They don't talk about this much, but did you know if you started with the Earth with an average surface temperature of 100 to 90 degrees, 190 degrees on Earth, at the rate that it's cooling off, it would be cool solid in 30 million years. Why is it still so hot inside? See, if it's been around for billions of years, it should have cooled off a long time ago, but it hasn't. Did you know our sun is losing weight? Did you know that? It's shrinking. Actually, some scientists believe about 5 feet of mass per hour. That's an awful lot, but it's real big, so you hardly notice. But now we're going to use some uniform processes, you know, uniformitarianism, just these uniform processes, just going, you know, natural processes over millions of years. That's what scientists believe today, many of them. So now there's some debate over this, but if the people who say it's not shrinking, they get and run into some other scientific problems. But so let's say those who do believe it is thinking, let's say that they're right. If you take off, that's 2.5 foot off each side per hour. Now think about this. If it's getting smaller, that means it used to be what? Bigger, okay? Very good. Now this is going to sound a little bit like Sesame Street or something, okay, for a few minutes, but this is some of the younger kids can help us out here maybe. If it used to be bigger, how much bigger can you get before you make life on Earth very uncomfortable? Do you know at that rate, if you can go back just 22.4 million years, the sun would have been touching Earth's orbit. That could get real uncomfortable in a big hurry. Now, do you know we have 2 planets closer than we are, Mercury and Venus, and Mercury would have been consumed in 5 million years. But it's still there and it's still doing real fine. So here's another thing to think about, some scientific evidence to throw in here, just for us to contemplate. Saturn's rings are unstable. You know they should only last a few thousand years? What formed them, and I have a theory about that also, and why are they still here? They should be gone by now, but they're not. How come they're still here if they've been doing that for billions of years? Did you know our moon is leaving us? Now think about this. If the moon is getting farther away, that means it used to be closer. I see some of the younger ones still have a little problem with this. Let me explain it this way. Today, boys and girls, we're going to talk about near and far. Near and far. Thank you very much. See, even on Sesame Street, they're told about near and far. Well, if it's getting farther away, that means it used to be closer. How much closer can you get before you make life on Earth very uncomfortable? Because the moon affects the tides. Do you know some have estimated even 30 million years ago, the moon would have drowned everything on Earth twice a day? You know, they've proven in laboratory tests you can only drown comfortably once a day. So that would be a little bit difficult. Did you know that Jupiter, the largest planet in our solar system, spins rapidly? It's spinning faster, so they have shorter days in relation to the sun. Did you know that you spin a planet faster and you increase the wind speed, the Coriolis effect? The winds rage at greater than hurricane force all the time on Jupiter. Why is that a problem? Well, on Saturn, our second largest planet, it has shorter nights and days because it's spinning faster. They have 1,000-mile-per-hour winds on Saturn all the time. Why is that a problem? Because you see, the Earth is slowing down in its rotation. It's going about 1,000 miles per hour at the equator, but it's slowing down. Now, as this gets slower because of gravitational pulls and that, there's a lagging motion. Dr. Ross, in his book, Creation in Time, he says this: the Earth's rotation period has been slowing down at exactly the same rate over the last 400 million years. And that's his emphasis on exactly, not mine. Okay? Can he know that? Last week, I think we talked about things we can know and things we just think. We might believe that, but can we know that, like I said, Dr. Ross, how do you know that 300 million years ago something didn't happen to alter that? Do you know somebody that was there that I don't know about? Or you've seen some documentary by somebody, filmed this. No, that's not something you can know. Now, you can believe that if you want to, but you shouldn't say that it's been slowing down at exactly the same rate, because you can't know that. You don't even know what it was like before they started testing it. A few thousand years ago, he doesn't even know if anything happened, like maybe 4,400 years ago when there was a great flood, and that would have quite an effect on it. But let's say he's right. If he's right, and it's been slowing down at the same rate for the last 400 million years, and then remember I told you, anytime somebody says something happened 1 million years ago, they made it up, okay? When they say something happened 4.6 billion years ago or 400 million years ago, that means, I'm going to interpret that for you, that means once upon a time, long ago and far away, okay? There's a fairy tale coming shortly. Now, here it says a second is added to our clocks every 10 to 18 months, Greenwich Mean Time. You know why? Because the Earth is slowing down, so they add a second to the clock at midnight to make up for that, to keep our clocks balanced. Maybe you woke up one night at midnight and you thought, what was that? See, next time you know, they probably just added a second to the clock or Greenwich Mean Time so you can go back to sleep. But see, it's called leap second, adding the second to the clock. Now, here's the problem. If it's getting slower, that means it used to be going faster. How much faster can you get before you make life on Earth very uncomfortable? A friend of mine, Greg Smith, he's a scientist, lead forecaster over here at White Lake, Michigan, National Weather Service. They factored everything, the Coriolis effect and everything that knew would affect this, factored in their computer. He said just 80,000 years ago, you would have had 500 miles per hour winds on Earth. You go to 1 million years, now you're up to 5,000 mile per hour winds. And they know this is true because of how it works with the other planets. This is just good science. That could be a real problem. Back about 2 million years ago when they said man evolved, it would be like, get up, go to bed, get up, go to bed. You're like, if you're going so fast you wouldn't get anything done. And now I've come up with, I'm going to share with you tonight the Edgeworth's dinosaur extinction theories, okay? You will not find these in any science textbook, I guarantee you. I think I'll write one someday and put these in there, but these are my dinosaur extinction theories. Now, maybe the sun was so big they fried. That's just one possibility, okay? The sun just got so big, man, or maybe the moon was so close the high tides caused them all to drown. And they finally said, we're getting tired of drowning twice a day. We're just going to quit. Or maybe the Earth was spinning so fast that it just sent them all into orbit. Pew! There goes another one. Now, I have not seen those in any science book, but maybe we can get some in. Now, did you know that magnets lose their strength over time? They get weaker. Did you know the Earth's magnetic field, by the way, which protects us, it protects us from radiation, the magnetic field. As it gets weaker, there's more carbon-14 being formed in the atmosphere. When they try to measure carbon decay, they're using a rubber ruler. We're going to get into that later, but as it's getting weaker, did you know that you go backwards, and if it's getting weaker than it used to be, stronger. If you go back even 25,000 years ago at that rate, it would have created so much heat because it measures, it's a way of telling how hot it is in the Earth's core, the strength of the magnetic field. It would have created so much heat that you couldn't even live here just 25,000 years ago.